Hello, my name is Jackson Mohr, and I am a undergraduate psychology major at the University of Oregon. Over the last summer, I researched heart-brain interactions, specifically the reliability of EEG oscillations and heart rate variability. I started my research with the question of how do the central and peripheral nervous systems, the heart and the brain, support cognitive and emotional states. The first goal of this research was to establish test-retest reliability of electroencephalography, EEG, brain rhythms in a baseline task. The baseline task we used was sitting participants down and having them watch a relaxing 5-minute video that depicted ocean life. And the second goal of this research was a meta-analysis of the effect of sound and music on heart rate variability, HRV. This summer, I gained experience in four main research areas: literacy, data acquisition, data analysis, and documentation. My advisor planned tasks to give experience in each research area in a relatively short period of time, that is approximately 9 weeks. Many measures were taken to build my literacy in this field of research, as I knew little about EEGs and HRV before conducting this research. For goal one, I started by completing an EEG training course offered by Pursue, which taught me how to start and operate EEGs, and more importantly, what an EEG is and how it works. I then was trained on how to use data analysis software known as MATLAB, as well as EEG Lab, which is a software on MATLAB. Specifically, I learned how to pre-clean/reject artifacts in EEG recordings and how to conduct independent component analysis on EEG recordings after they have been pre-cleaned using EEG Lab for both. For goal two, I conducted a literature search using PubMed and APA PsycNet to compile a list of non-review articles relevant to the meta-analysis. I stored these relevant articles on a software called Zotero so that I could refer back to them easily if I needed to. Lastly, I looked for articles relevant to the meta-analysis that I couldn't include in the meta-analysis because they themselves were reviews. Um, and I performed an annotated bibliography on them so that I could get a better idea of how similar studies are being performed in the literature. For goal one, I learned how to build open BCI EEGs using an open BCI kit, as you see in figure one, and attach them to someone and sync them with my computer's open BCI software and record data. In fact, the photo of myself at the beginning of this presentation is one of me wearing the first open BCI EEG I built, with it still attached to my head, recording my scalp data. I thought that was pretty cool. For goal two, I coded 871 articles from APA PsycNet for relevance to the research question. And my colleague recorded a similar amount from PubMed. As you can imagine, this took a long time to complete and was very tedious. At the end of the screening process, we were left with a combined total of 28 non-review articles from APA PsycNet and PubMed that were used in the meta-analysis. So for goal one, data analysis involved MATLAB, EEG Lab, data cleaning. This was a two-step process. The first step, data pre-cleaning, I finished by the end of the summer. This involved looking for and rejecting artifacts, as you see in figure three, the section I have highlighted. Um, Typically, artifacts occurred in the form of interference caused by muscle movements in the face, such as the clenching of the jaw or blinking that interfered with our data gathered from the scalp. However, artifacts also rarely yet occasionally occurred in the form of the movement of electrodes / difficult electrode placement. Although blinks were a form of artifact, blinks and other eye movements were removed in the second step, independent component analysis, for the sake of preserving data. And you can see that in figure 4, independent component analysis. In the second step, which is still in progress, by the end of the summer, I removed horizontal and vertical eye movements from the data. Scalp topographies, as depicted in figure 5, assisted me in this process as they enabled me to see where on the scalp electrical signals were coming from. So, taking a look at figure 5, for example, IC2 and IC7 are components to be removed, as the electrical signal is coming from the facial region of the head. The process is a little more complex than that, but that's just a brief overview. For goal 2, data analysis involved compiling meta-essentials from the 28 non-review articles that made it past the screening process. These meta-essentials included high-frequency HRV, low-frequency HRV, PNN50, RMSSD, and SDNN. These are all different measures of HRV. Following uploading these meta-essentials to an Excel spreadsheet, I helped make a Prisma flow diagram of the rigorous screening process. This showcased the yields of our literature search and each successive exclusionary decision made until we were left with our 28 non-review articles that were included in the meta-analysis. The primary means of documentation used was a lab journal that detailed my day-to-day progress of the 30 to 40 hour work week of research over the summer. This helped document and track and keep up with the work assigned to me. In addition, this lab journal was greatly beneficial in creating this SurfCure research presentation. Funnily enough, this SurfCure research presentation is also a part of the documentation process. In conclusion, for task 1, I successfully learned hands-on EEG data collection using OpenBCI, EEG artifact rejection through pre-cleanings, and ICA artifact identification and removal. Though the other goals have been completed, the last goal of task 1, ICA artifact identification and removal, is still in progress, though nearing completion, meaning that test-retest reliability will be completed by the end of the term. For task 2, I successfully contributed to my colleague, Megan Ramirez's meta-analysis of the effect of sound/music on heart rate variability, HRV. And the manuscript will be submitted with the rest of my team by the next term. Both of these tasks helped me improve my skill set as a researcher. This skill set includes, but is not limited to, time management, learning how to use new means of data collection and analysis, and expanding my horizons in area of interest. I want to take this time to give a special thanks to my research mentor, Dr. Christina M. Karns, who assisted me throughout this process, as well as my exceptionally talented colleagues, Tommy Monkarsh, a University of Oregon undergraduate student, and Megan Ramirez, a University of Nebraska graduate student. In addition, this summer research opportunity would not have been possible without the SurfCure Summer Research Award, and I am enormously grateful for it. Thank you all for watching. Have a wonderful day.